Hi guys, welcome to SUDEEPVERSE, and I hope each and every one of you are doing really good. Now this is episode 2 of Prelims Affairs, where we discuss current affairs from Prelims perspective. Now today's issue is carbon capture, utilization and storage, and we are discussing this because in the Union Budget 2026-27 it was announced that rupees 20,000 crore will be earmarked for the advancement of carbon capture, utilization and storage in India. Now before we understand what is carbon capture, utilization and storage, it is necessary that we understand what is geoengineering techniques. Geoengineering techniques constitutes many techniques, and one among them is carbon capture, utilization and storage. Now also understand that geoengineering techniques is something that has been asked from the last 3 years in the UPSC Prelims environmental subject, so please make sure that you pay attention to whatever we are going to discuss. Geoengineering techniques is engineering solutions done through human interventions in order to mitigate or reduce the effect of climate change. Now, geoengineering techniques can be segregated into two types. One, I can mitigate the effects of climate change by reducing the amount of incoming solar radiation into Earth. This method is known as solar radiation method. Or I can remove the carbon dioxide that is already there in the atmosphere. This method is known as carbon dioxide removal method. Okay, so now you have two methods of geoengineering techniques. The first method is solar radiation modification. The second is carbon dioxide removal. Now under solar radiation modification there are three important subtypes. The first is stratospheric aerosol injection, in which sulfur dioxide aerosols are added in the stratosphere. Why stratosphere? Is because stratosphere does not have any type of turbulence, and because it is more stable, the aerosols added there will stay for much longer period and can reflect back the incoming solar radiation. The second method under solar radiation modification is marine cloud brightening. Now why do they choose stratocumulus clouds present over oceanic areas? Is because these clouds are much more flatter and much more wider. Now when I say brightening, in this case it means whitening. Now how do we whiten the cloud? We can whiten the cloud by breaking the water droplets into finer particles, and when we break it into finer particles, the clouds will become much more whiter, and when they become much more whiter, they have better albedo and can reflect back the incoming solar radiation. So this is how marine cloud brightening works. The third technique under solar radiation modification is space mirrors. Space mirrors is where we place reflectors outside the Earth that will reflect back the incoming solar radiation. However, this is very complex and still theoretical and unpragmatic. Now we have just understood the different solar radiation modification methods that comes under geoengineering techniques. Now let us understand the different carbon dioxide removal methods under geoengineering techniques. Among them, these are the four important ones. The first is direct air capture, the second is biochar carbon removal, and the third is enhanced weathering, the fourth is ocean alkalinity enhancement, and the fifth is the most important issue that we are discussing today, and that is carbon capture, utilization and storage. The first technique under carbon dioxide removal method is direct air capture. Now as the name suggests, this technique tries to capture carbon dioxide directly from the air. It mimics a tree, because just like a tree which absorbs carbon dioxide during the process of photosynthesis, this technique also tries to absorb the carbon dioxide directly from air, just like mimicking a tree. Now the only difference is, visualize that this direct air capture works like a mechanical tree. Now when you coat this particular mechanical tree with a solvent, the most popularly used is amine solvent, and within amine solvents the most popularly used is polyethylene imine, PEI. So when you coat that mechanical tree with this solvent will absorb the carbon dioxide that is present in air, and this is what is direct air capture. The second type under carbon dioxide removal method is biochar carbon removal. Now biochar is when you take a biomass and heat that biomass in the absence of oxygen. That is when you get biochar. Biochar looks like a charcoal, but this biochar has a lot of carbon content that is locked in it for thousands of years, and that is the advantage of biochar. So you understood what exactly is a biochar. Now if I take the same biochar and increase the porosity of that biochar, then you call it as activated carbon. Why do I call it as activated carbon? When I increased the porosity, it increased the surface area, and that in turn increased the adsorption capacity of that particular biochar. This is what is called activated carbon. So this technique is what is called biochar carbon removal. The third technique is enhanced weathering, and the fourth technique is ocean alkalinity enhancement. In both these techniques, one thing what you should understand is carbon dioxide is readily soluble with water. When it dissolves with water, it forms carbonic acid. Now when this carbonic acid comes in contact with an alkaline material, when acid comes in contact with an alkaline material or a base, it neutralizes. So basically this science is taken and applied in these two techniques, that is enhanced weathering as well as ocean alkalinity enhancement. So the third technique is enhanced weathering, where on a large scale we spread the basaltic rocks. Why basaltic rocks is because these basaltic rocks are rich in alkaline materials such as calcium, potassium and magnesium. When this atmospheric moisture that contains carbon dioxide inside them, that is what is carbonic acid, when this atmospheric moisture with carbon dioxide comes in contact with alkaline material, the carbon dioxide will convert into calcite, and when it converts into calcite, it becomes a solid form and gets locked in the rock, and that is what is enhanced weathering techniques. The fourth technique is ocean alkalinity enhancement. Now this also works on the same lines of enhanced weathering. The only difference is we had alkaline material over oceans, and those alkaline materials will react with the carbonic acid and neutralizes the carbon dioxide and turns it into a form that gets locked in the oceans. So this is what is ocean alkalinity enhancement. Now let us go to the fifth type of carbon dioxide removal method, and that is carbon capture, utilization and storage. Remember one thing, carbon capture in this technique does not involve directly capturing carbon dioxide from air. It involves capturing carbon dioxide either from flue gas or syngas. Now understand carefully that there are two important subtypes under carbon capture, utilization and storage. The first subtype is post-combustion process and the second subtype is pre-combustion process. First, let us understand what is this post-combustion process. Post-combustion process is nothing but capturing the carbon dioxide from flue gas. Flue gas is nothing but exhaust gas. Exhaust gas is when the gases that are released when you burn a biomass. So from that exhaust gas or a flue gas, when we try to capture the carbon dioxide, this is what is the post-combustion process. Now in this process, we try to use a chemical solvent, and the most popularly used chemical solvent again is the amine solvent, and within the amine solvent we have monoethanol amine, MEA. Now this is a chemical solvent and not a physical solvent. What does it mean? It means when the exhaust gas or flue gas is passed through the chemical solvent, the carbon dioxide present in the flue gas will convert into a chemical compound. Now that is the function of chemical solvent like monoethanol amine, that is MEA. So we understood what is post-combustion process of carbon capture, utilization and storage. Now let us understand what is pre-combustion carbon capture, utilization and storage. In pre-combustion carbon capture, try to understand something called syngas. What is a syngas? A syngas is released when I burn a biomass in the absence or very limited oxygen. When I do that, the biomass releases syngas. That syngas constitutes carbon dioxide, carbon monoxide, hydrogen and methane. Now from this syngas, our objective is to remove the carbon dioxide, and that is done through pre-combustion carbon capture, utilization and storage. Understand one very important fact, that is in the pre-combustion carbon capture, we use physical solvents and not chemical solvents. Now what is the difference? In chemical solvents, the carbon dioxide will change into a chemical compound, but in physical solvents, when the syngas is passed through the solvent, the carbon dioxide just gets dissolved and does not change into a chemical compound. Now in the pre-combustion carbon capture, where we are trying to capture carbon dioxide from the syngas, there are two subtypes. One is Selexol and the other is Rectisol. The difference is in the solvents that they use, but understand that they are both physical solvents. Now in the Selexol process, the solvent that is used is dimethyl ethers of polyethylene glycol, whereas in the Rectisol, the solvent that is used is methanol. One more difference is in the Selexol process, the gas is passed at high pressure, and in the Rectisol process, the gas is passed at very low temperatures. Apart from this, both are physical solvents and both are process of capturing the carbon dioxide from the syngas. So I hope you understood what exactly is carbon capture, utilization and storage and how the mechanism works, and I also hope you understood a much more broader concept, and that is geoengineering technique, which is repeatedly asked in the UPSC Prelims exam. Last bonus information for you is Department of Science and Technology is establishing 5 important carbon capture utilization test beds across India, and those 5 locations are Sundargarh, Odisha, Chittorgarh, Rajasthan, Rajgangpur, Odisha, you have Kurnool in Andhra Pradesh and Reddypalayam in Tamil Nadu. These are the 5 places where Department of Science and Technology is establishing carbon capture utilization test beds in order to understand the working of carbon capture utilization in reality. So I hope the information was helpful, and I hope that you people will put in more efforts to understand these techniques, which are very, very important for the upcoming prelims. Thank you so much for all the love and support. I'll meet you in episode 3. Bye.